Spice Math. That's right. We add it up, multiply and man, Spice Math. Okay. A couple things we're gonna learn today, Spice Math. All right. Take some time, educate yourself, Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math, just math.
Hello, welcome again to Spice Math 2020. And we would like to continue the lessons we started on number bases. I'd just like to take this opportunity to wish everyone all the best. Be safe and practice all that you need to practice to keep hygiene and health up and working. We're on to number bases, and in today's lesson, we'll be looking at what happened in the lesson before, how we expand the numbers in base 10. And many of you may remember this from way back in primary school, and how you can take a base 10 number and expand it. And then we want to look at how you change from another base back to base 10. Okay, in a previous lesson, we looked at how to change from base 10 to base 8, or from base 10 to base 5, and that was through division. In the lesson today, we'll be looking at how to go from base 5 to base 10, or base 8 to base 10. Let's review quickly. I have a base 10 number on the board, and it's 1080. And we're going to look at how you can expand that number in base 10 by taking a note of the value of all the columns and all the positions, otherwise known as the place value. Okay, so let's go to the board. 1080, we always start on the right of the number because the rightmost position would be the units. So 0 multiplied by 1 to represent the units, plus 8. What position does the 8 have? Right, we can see here that the position of the 8 is the tens column. So the value of this digit would be 8 times 10, or 10 to the power of 1, plus 0 times hundreds, or 10 to the power of 2, plus 1 times 10 to the power of 3, representing thousands. So this is how you expand an ordinary base 10 number by keeping track of the value of each place or each position in the number. Now let's work it out. 0 times 1 is 0. 8 times 10 is 80. 0 times 10 squared, or 0 times 100, is 0. And 1 times 10 to the 3, which is 1,000. So 1 times 1,000 is 1,000. Now let's see. If we add up these numbers after we expanded them, we should get back the number that we started with. Are we going to get it? 1,000 plus 0 is 1,000. 1,000 plus 80 is 1,080. 1,080 plus 0 is 1,080. So we did get 1,080. So now you can take some time and see if you can try these two for me. Two numbers in base 10. Take 5 minutes. And I'd like you to write it out using the brackets and the multiplication for each position or each place in the number. Okay, so now you've tried those on the board. Let's see if you got them right. Number 1, 396 is 6 times ones, or 10 to the power of 0. We're going to put that power for ones, plus 9 times 10 to the power of 1, or tens, plus 3 times 10 to the power of 2 for the hundreds column. Let's see what we get from that. 6 times ones, 6. 9 times 10, 90. 3 times 100, 300. Now let's add this up and see if we get what we started with, just to check we're correct. 300 plus 90, 390, plus 6, 396. Answer? That's correct. And if you did the second one, and you did it correctly using the different values for the places, you should get the answer as you work it out. Now let's see, how does this apply in other bases? So far we've been working with all the numbers in base 10, and in a previous lesson I remember saying to you that if we work in base 8 or base 5 or base 2, it's just a matter of rearranging the groups of 10 from base 10 into groups of 8 if we're working in base 8, or into groups of 5 if we're going to convert to base 5. Okay, so we're now going to look at a number in base 8 and see if we can expand it using the principles we've learned from expanding in base 10. Remembering that when we work it in base 8, we're now thinking in groups of 8, not groups of 10. So the number 213 base 8, once again, each place in that number has a specific value, and each place is guided by the base that we're working in. In this number, the first column would be would be ones. As in all bases, the very first column on the rightmost digit of all numbers would be ones or units. So that would be 3 times 1, or we can put in 8 to the power of 0 because we're working in base 8. For the 1, what do you think it would be? Would it be tens? No, we're not in base 10. We're in base 8. So the first position to the left of the 3 would be 8s. 1 multiplied by 8 to the power of 1 because we're working in base 8. And the third position, counting from the right, the 2 will be 2 multiplied by 8 to the power of 2, because this number is not 213. This number is 213 base 8. Okay, remember hundreds and tens and ones are for when we're working in base 10. When the base changes, we have to think now in the group or in the base that we're working with, and in this case is base 8. Let's work it out. 3 times 1, 3. 1 times 8 is 8. And 2 times 8 squared. How much do you think 8 squared is? 8 times 8, which is 64. So 2 times 64 is 128. Okay? Now when we add up these, let's see what we get. 3 plus 8 are 11, and 8, 19. 1 and 2 is 3, carry the 1. What we have done is, we've now converted 213 in base 8. Through expansion, we've converted this to base 10. And you see, the same principle of expanding numbers in base 10 works in all bases. Now, in a previous lesson, you saw how when we converted from base 10 to another base, we used division. Here, we're converting from another base back to base 10. We're using an expanded form of multiplication and addition. Do you think you can try some on your own in base 8? Let's try these. Very well. So now you tried those that I gave to you. Let's see what you got as we convert them to base 8. 304 base 8. Remember, we're thinking in groups of 8. So that would be 4 times 8 to the power of 0 for the units column. 0 times 8 to the power of 1. So that will give us the 8ths column. Okay, it's not the tens column, it's the eighths column because we're working in base 8. And plus 3 times 8 to the power of 2. Already we know that 8 to the power of 2 is 64, so we'd have to do that multiplication. Let's work it out. 4 times 1 is 4. 0 times 8, 0. And 3 times 64. 3 4s are 12. 3 6s are 18. And 192. Now we can add these up, and the result would give us the conversion of 304 base 8 to base 10. And that's 192 plus 0 plus 4, that's 196. So the number 304 base 8 is equivalent to 196 base 10. Let's do the second one. First number, 5 times 8 to the power of 0 plus 7 times 8 to the power of 1 plus 1 times 8 to the power of 2, because we're in base 8 and we're converting that base 8 number to base 10. 5 times units would give us 5 times 1. 7 times 8 give us 56. And 1 times 8 squared give us 64. Let's add this up and see what we get. 5 and 6 are 11 and 4, 15. 1 and 5 is 6 and 6 is 12. 125. So the number 175 base 8 is equal to 125 base 10. Very well, so now that you have done the expansions of the numbers in base 10, and we've used the same principle to do base 8, the very same strategy can be used in base 5 and in any other base, once you're converting from that base to base 10. So I'd like you to practice with this activity that we've had here set up for you, and then show you follow the examples that were given before, by putting in multiplication in brackets and doing the addition at the end. Let me wish you all the best as you practice your mathematics. Thank you very much.
A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on. You won't believe it's just math. Spice Math, that's right. You add it up, multiply it, man. Spice Math, okay. A couple things we're gonna learn today. Spice Math, all right. Take some time, educate yourself. Spice Math.